The square root of 9, is it 3? Or is it negative 3? Or is it both? I mean, what is it? Let's check it out. Now right here, remember, the definition of the square root of x squared is actually defined to be the absolute value of x. So whether I put in 3 or negative 3, it actually doesn't matter. The absolute value, right, of either one is actually 3. So the square root of 3 squared or the square root of negative 3 quantity squared is still going to be the absolute value of either one, which is going to be what? Only one answer, 3. Another way you can see why there's only one is to take a look at the square root function. Remember, in order for a relation to be a function, every input can only have one output. So if I input that x value of 9, that output is going to be only 1. It's going to be 3. See, 9 negative 3 is all lonely right down here. Now, when do you get two solutions? That's a great question. I'm glad you asked. That happens in the context of solving a quadratic. You see, in the problems before, I wasn't solving a quadratic equation. But look here, Pythagorean theorem, right? Isn't that what I write? And I get an equation now. This is a quadratic equation. It's a very simple quadratic equation, but every quadratic always has two solutions. So here I have to acknowledge the existence of both solutions. X can equal the positive or negative square root of 9, which is going to be positive or negative 3. So I can acknowledge the existence of both solutions, but granted, since I have a right triangle here, I'm just going to go ahead and write, hey, x could be 3 or x could be negative 3. But since we're talking about a side length here, length can't be negative, I'm going to throw that one out. And I'm going to keep the positive one here. So again, we can only have two solutions in the context of solving a quadratic. But in the problems before, I didn't have a quadratic equation. I just had a simple expression, so there's only one output, and that answer is 3.